So first of all, we need to make sure we review our formulas, okay? Oh. So the pattern for the sine is what? Sine, cosine, cosine, sine, and we keep or change the sign? Keep. So this would be sine of u, cosine of v, plus cosine of u, sine of v. And then it would be the reverse. If it was minus, it would just be minus. Cosine's pattern is? Good. Cosine, cosine, sine, sine. Keep or change? Change. So cosine u, cosine v, minus sine u, sine v. And it would be the opposite. If it was minus on the left, it would be a plus on the right. And then tan. And tan is the sum or the sign that matches in the numerator. So tan u plus tan v over one opposite sign, one minus tan u times tan v. If you can remember at least one of them, you should be able to get to the other. Because the only thing that changes is the signs. All right, then obviously we need our unit circles because we're going to reference it a bunch. And on Monday, end of class, we're going to fill out that unit circle again. This time I would say you don't have to add on the negatives and the sine tangent thing because that was for inverse functions and we don't need those. Well, let me group it. But I would still add on the tangent values. So I would add on my tangents are 0, root 3 over 3, 1, root 3, undefined. We can go all the way around. 0, negative root 3 over 3, negative 1, negative root 3, positive root 3 over 3, 1, root 3, negative root 3 over 3, negative 1, negative root 3. All students take calculus. And I would go so far as if you wanted to, God bless you, if you wanted to add yourself a note for the plus 2 n pi and the n pi, like for tangent without the interval, we only use from 0 to pi and we add n pi. And for cosine and sine, we use the full circle, 0 to 2 pi plus 2 n pi. Like if you wanted to add that on tomorrow, that's fine. Oh, that blue-green is really hard to see. Okay, so now given that, number 1 says find the sine, the cosine, and the tangent of the angle, and it just gives you the angle already added together. So if I needed to break this down into 2 angles, I can either find 2 that add up to it, or I can find 2 that when I find their difference, it's 195. Give me an example of one of them. 150 plus 45. So I'm going to find... And you could go 150 plus 45 or 45 plus 150. It doesn't matter. So if I did, I'm just going to go based on the way you just said it. So 150 plus 45. So now I'm going to find the sine of 150 plus 45. And that is sine, cosine, cosine, sine. Keep the sine. So sine 150, cosine 45, plus cosine 150, sine 45. Now on your test, it's only going to ask you for one of the 3. It's not going to ask you for all 3. But we're going to do all 3 because you could get any of them. Cosine 150 plus 45. And the pattern for cosine, 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 sine, sine, flip the sign. So cosine 150, cosine 45, minus sine 150, sine 45. And then the tangent. Match the sign in the top, so tan 150 plus tan 45 over 1 minus, change the sign in the bottom, tan 150, tan 45. And then I would go to my unit circle and I would locate 150 and 45. Hopefully 45 we know by now.
Excuse me.
Yep.
For tangent, on the top part, do you switch the sign if it's...
No, the top always matches the sign.
Oh, okay.
The bottom is the opposite sign.
Okay.
So the sine at 150 is 1/2. The cosine at 45 is root 2 over 2. Cosine at 150 is negative root 3 over 2. And the sine at 45 is root 2 over 2. And I get root 2 over 4 minus root 6 over 4. And then I just combine them because they have the same denominator. Then cosine would be root 3 over 2, negative root 3 over 2, sorry, and root 2 over 2. Nope, yeah. Minus sine of 150, which is 1/2. Sine of 45 is root 2 over 2. And I get negative root 6 over 4 minus root 2 over 2. So I get negative root 6 minus root 2 over 4. Oh, this should be 4. Then I go to tangent. Tangent at 150 is negative root 3 over 3. So I get negative root 3 over 3 plus tangent at 45 is 1 over 1 minus negative root 3 over 3 times 1. I get negative root 3 over 3. I'm going to change it so it has a like denominator. Plus 3 over 3 over 1 plus root 3 over 3, because it's minus a negative, becomes 3 over 3 plus root 3 over 3. Negative root 3 plus 3 all over 3 over 3 plus root 3 over 3. And then we keep, change, flip it. Yep.
Could you use any 2 degrees on the unit circle that add up to 190?
Correct. Or difference. You could do a difference too. Yep. The order might be different in the end, but your, like, as long as your signs are right, the values will be the same. Yep. Yep. All right, 2, find the exact value of the expression. So sine, cosine, cosine, sine is what pattern? Sine. And with sine, do we keep the sign or flip it? We keep it. So I'm going to do sine of 120 minus 60, and I get sine of 60. And what is the sine at 60 degrees? Good. And then 3 is tangent, right? Tangent's pretty obvious, but where do I match the sine? To the top or the bottom? The top. So this would be tan of 25 plus 110, tan of 135. And the tangent at 135 is negative 1.
Can you fill out the tan on the unit circle?
Yep, everything that's on. All right, so first thing is, because they all start with 4, I would have gotten rid of the 4. You don't have to, but just to make it easier, because they were all divisible by 4, and each of you had different numbers there, but they all 3 had the same number. So if I just started with that, if I divided by 4, I would have gotten cosine of x plus 7 pi over 6 minus cosine x minus 7 pi over 6 equals negative 1. Then these are each their own individual sum or difference expressions. So for cosine of x plus 7 pi over 6, I'm going to expand that. It's cosine, so it'd be cosine x cosine 7 pi over 6 minus, because we do the opposite sign, sine x sine 7 pi over 6. Minus, and that minus is going to go to everything after, so I'm going to keep it in parentheses for now. Cosine x cosine 7 pi over 6 plus, because we flipped the sign from here, sine x sine 7 pi over 6 equals -1. Then 7 pi over 6 is an angle on our unit circle that we can actually find the values of. It's -√3/2 and -1/2. So I'm going to leave cosine of x as cosine of x, but cosine of 7 pi over 6 is -√3/2. Minus sine of x stays as sine of x. Cosine at 7 pi over 6 is -1/2. The minus is going to go to both, so I'm going to do both at the same time. Minus cosine of x, and then cosine of 7 pi over 6, again, -√3/2. Minus sine of x, sine of 7 pi over 6, which is -1/2, equals -1. Then I would simplify these. Like if I rewrite it so it's easier to see the coefficient, that is -√3/2 cosine minus a -1/2 comes forward. That would be a +1/2 sine of x. Bring this forward, it's plus cosine of x, or plus √3/2 cosine of x. Bring this to the front, plus 1/2 sine of x. You didn't have to bring them to the front because still this one is going to cancel because it would have been a problem if they were two different trig functions there that were not squared. We couldn't replace them with its Pythagorean identity. Now from here I can combine these. So +1/2 and +1/2 is +1 sine of x equals -1. And then you'd go to your unit circle and you'd find where sine is -1, and that's at the bottom at 3 pi over 2. There will be a question using sum or difference within a solving equation on your test. There will be an equation or something where you have to verify an identity using sum or difference, which was the second to last example yesterday. That's how those verifying are going to kind of get built back into your test so that it wasn't all verifying from 5.1 and 5.2. Yeah.
Is that how the last question was answered?
Yes.
Okay.
Yep. And I did it on the video, but obviously we didn't get time to do it in class. So if you want to see another example, it's the last one from the video yesterday. Questions? Okay, so if you opened this, you've got it in front of you. That's the idea behind it, okay? So you don't have to write everything out. This first page is all the stuff you have to know on that blue box. So this is your blue box just written out again. If you are a person that requires like rewriting something to learn it, then you have a lot of this stuff to rewrite. Hopefully by now we know like the reciprocal identities, like those we've used so many times that hopefully we're getting better at. But if you want to rewrite this page until you know it, then do it, okay? They're gonna show up in different ways. There is a Quizlet. So I made a Quizlet class because you guys like, so that Quizlet doesn't make you create an account and like pay to do like the tests and stuff. I made a Quizlet class and the link is on the homepage, like on the bottom of all my information, there's a thing that says Quizlet there. It will take you to the class, and there is a Quizlet there from all the formulas from 5.1 to 5.4. So it has all this stuff that's on this slide, and it has sum and difference equations. So if you're a Quizlet person, you're a flashcard person, and you need to review it, do it that way. But this is everything you need to know. So at the top, reciprocal and then co-functions. In the middle, the even odd functions. On the bottom, the Pythagorean identities. So these are your Pythagorean identities, those three. If you forget, then this is the shortcut to finding them. So I find the first one, and then I take everything, divide it by cosine squared, and that gives you the second one. Take the first one, divide everything by sine squared, and that gives you the last one. All right, so let's do some practice because it's been a little while. So this is just 5.2. It says the no, it's actually 5.1 because it doesn't give you the other side. This would be 5.1 or 5.2. So without the equals, it's 5.1. God bless you. So what is there in number 1 that we can substitute? God bless you. Good. 1 plus tangent squared is in your Pythagorean identities, and it is secant squared. And then secant squared becomes what? 1 over cosine squared. And from there, you can cancel one of your cosines. And I get 1 over cosine, which is? Good. Go to 2. What can you do on that one? Good. Take out a cosine. One has cosine to the third and the other one has just cosine to the first. So I can take out one cosine. And I'd get cosine squared plus sine squared. Oh, theta. And what is cosine squared times sine squared? 1. All right, sine of x plus 1 over cosine of x. Is there anything you can replace? No, it's not squared, right? There's no reciprocal functions. What do you do when you're at a dead end and there's a binomial on the top or the bottom?
Bring it to top.
I could bring the cosine to the top, but it's just going to make it its reciprocal function, right? So we did something when we got to like a place in which we couldn't do no other. And it involved a binomial and a fraction.
You split it.
Okay, we could split it. So this could become sine of x over cosine of x plus 1 over cosine of x. And sine of x over cosine of x becomes tangent of x plus 1 over cosine of x, secant of x. Can you go any further from that? You're just going to be back where you started, right? What happens when you get stuck also is you can multiply by the opposite of the binomial, remember? So like I could take and I can multiply this by sine x minus 1 and this by sine x minus 1, as long as I do the same in the top and the bottom. And then the numerator becomes the difference of two squares. Sine x plus 1 times sine x minus 1 becomes sine squared x minus 1 over, and I would keep it out, cosine of x times sine x minus 1. What is sine squared x over sine x minus 1? Cosine squared x over cosine x sine x minus 1. And in here, the cosine cancels, and I get cosine x over sine x minus 1. I would give full credit to each of these answers if it was open-ended, if it was multiple, if not multiple choice, but if it was an equal to statement, and obviously one of those was the answer, you would have to know how to do both those processes. So if my answer was tan plus secant, I would have to do it the first way. If my answer only involved cosines and sines, I'd have to do it the second way.
Does our test have some multiple choice?
No.
No.
No. I feel like it will be disastrous. Yeah. All right, 5-3. So you're going to see like 5-1, 5-2 like that, where it's just like straight up verify. And then you're going to see it built into the stuff that we did here, like where we actually had to verify or replace things within the equations, which I'll get to in a second. But remember 5-3, there are two separate sets of instructions. If it just says solve, it is different than if it says solve on the interval of 0 to 2 pi. And the exception is your multiple angles, so I'll get back to multiple angles in a minute. But if it doesn't have a multiple angle, then when you're solving for sine and cosine, which it says it there, you're going to use the full circle. And you're going to add 2n pi. For tangent, you're going to use from 0 to pi, just the top, not including pi, and you're going to add n pi. If it says solve on the interval of 0 to 2 pi, you use the full circle for all of it. You don't add on the interval. And again, the exception to that is the multiple angle one, which I'll get to in a second. Yeah.
Those we include 0, but we don't include 2 pi.
Correct. Because and I'm not because it's wrong, but because it's a repeated answer. Yeah. All right, so we're gonna set these up, but I'm not gonna go all the way through because I feel like the multiple angle ones are the ones you need the review on, right? Okay, so this one, I would add the 3, divide by 4, then square root, putting my plus and minus on the front. And that becomes the square root of 3/2. And then I'd go to my unit circle. I'll just answer real fast because it should be relatively easy. But I would go to my unit circle and I would locate everywhere. The x is √3/2 because it's positive and negative. This is going to be all the over 6's. So if it's on the interval, it's pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. If it didn't have this instruction, it would be those same answers plus 2n pi. Good. And again, if it was multiple choice, then that's where it gets tricky. If it was multiple choice, it would cut those answers in half and add n pi. They're both right. But I think the other one throws you off. All right, these ones involve multiple angles. So when you have a multiple angle, and I know it because there is something attached to the x, then when it says solve, we would solve on the interval of 0 to 2 pi or 0 to pi if it's tangent, and then change your interval and your angle. So solve and change the angle and the interval. And usually those are the easier ones. But with multiple angles, this is where it gets more complicated. Solve with the interval means we have to do that, and then we have to find each of the answers within the interval. So we don't add on the n pi at the end of my answer, but I add it on to find the interval. So I'll kind of do it. We would add the 5, divide by 10, and I get sine of x over 3 equals 1/2. And then I would go to my unit circle. Notice the interval is not on this. So I would go to my unit circle. I'd find where sine is 1/2, and that is at pi over 6 plus 2n pi, and at 5 pi over 6 plus 2n pi. And then I would multiply everything by 3. And I get x equals 3 pi, 3 pi over 6, which becomes pi over 2 plus 6n pi. And then x equals 5 pi over 2 plus 6n pi. And then if it did have the interval, I would do exactly what we just did there first. I'd find the first angles using what's the given one, so pi over 2 and 5 pi over 2. And then I'd actually add on that interval and see if it would fall within my range. If I take pi over 2 and I add 6 pi to it, is it between 0 and 2 pi? No, so these are my only answers. But if it said something like pi over 2 plus pi over 3, I'd have to keep adding pi over 3 until I get all the answers within my 0 to 2 pi. Your review is posted. Please do as much of it as you can over the weekend so on Monday you come in with questions. And remember, you're going to fill in your unit circle on Monday.